Hi, everyone. I'm Jeremy Simon with 3D Universe, and thank you for joining us today. This is episode 6 of our ongoing series, 3D Universe Untethered. In this series, we sit down and talk with folks in the 3D printing and digital fabrication industry and find out what they're up to. And today is an episode that I've been looking forward to. This is going to be a talk with Mat Bowtell, and we'll be talking about the Kinetic hand, a fantastic new design for an assistive device that we'll get into a lot of detail about. So at this point, I'd like to go ahead and invite Matt and Jen to join me on video, and go ahead and unmute yourselves here. Jen, most of you know, Jen Owen is a co-founder of the Enable volunteer community, and she's also our creative director here at 3D Universe, and helps me with moderating these episodes. So Jen, thanks for joining us as usual.
Of course.
And I'm also very happy to welcome Mat Bowtell. And let me just get to my notes here. It's on the wrong tab.
Is Matt's video not working?
Matt, do we have your video here? Let me ask to start video, see if that works.
Yep, that's better.
There we go. Okay.
Hi, how you doing, guys?
Good. How are you?
Hey.
Excellent, thanks.
Excellent.
Hi, Jen. How you doing? Long time no see.
Great. Yeah.
So yeah, thanks very much for joining. I know we have quite a difference in time zones here. Matt, and so folks, Mat Bowtell is a 10-year veteran. He operated as a senior engineer with Toyota in Australia and Japan. And then it was announced that the automotive industry was going to be shutting down and that he would be made redundant. And so Matt had a big decision to make about his future direction. By that point, he had already had 3D printers taken over his lounge room, and after making one hand for a child, he knew that his decision was made. Matt turned down some lucrative consulting jobs and devoted himself full-time to designing and 3D printing hands and providing them to kids for free. Free 3D Hands has now provided hundreds of devices to people all over the world, and Matt has invested in some world-class CAD software and shares his designs open source with anyone who can access them for free. So Matt, again, thanks for joining us. Very excited to have you.
Oh, it's lovely to be here. Thank you.
Yeah.
Yes.
So we're going to be talking about this great new design here. I have one here, the Kinetic hand. Fantastic new design, and there's so much to talk about. That's not the only thing we're going to be talking about, because I know you got your hands into some other things, but that'll be our main focus today, because like I said, there's so much about this design that was impressive to me, not just the design itself, but how you went about it, the documentation, the organization of the files, just everything about it. And we'll talk through some of those things that make this unique.
Yeah.
Great. Wow. What a compliment. Thank you.
It's really awesome to see you again. I think it was a year or 2 years ago I came over.
I think, yeah, probably, yeah, a year and a half, I think.
Yeah.
When you came over to Melbourne and came and visited us on Phillip Island and drove on the wrong side of the road.
And the car.
Yeah.
Yeah.
And that was, I think, when I saw the Kinetic. That's, I think, when I saw the Kinetic hand first. That was probably the one that you brought back, Jen, right?
Yeah. Yeah, Matt sent it home with me. I actually got one of the first sneak peeks when he came over to the US and invited us to go get dinner with him and set this awesome hand on the table. And
yeah, several of us were kind of gawking at it at last year's EnableCon, because it was just so impressive. I mean, just the aesthetics of it really caught our attention, and so I was really excited when this got rolled out recently. And when I saw the package that it came with and the documentation and everything, I just knew that we had to have Matt on here to talk about it. So before we get into our discussion here, I want to invite our audience to please join in the discussion here. Use the Q&A panel there in Zoom. Please ask questions or make comments as we go, and we will bring those into the discussion either as we go or towards the end, depending on how the timing goes. But please do use that Q&A panel, and we'll keep an eye on that throughout the session here.
Yeah. So Matt, I think the first question is kind of, what is your background and how did you end up getting started with making 3D printed hands?
Well, as Jeremy mentioned, I was an engineer at Toyota, but before that, whilst I was still studying engineering through Monash University in Australia, they sent me over to Japan on a scholarship to study mechatronics. And it was during that time, back in 2004, that I had the opportunity to test and trial a $1 million bionic arm. And, I was very impressed by the technology, obviously. But at the same time, I was quite saddened that, at that price point, it wouldn't be accessible to large numbers of people around the world. Mm-hmm. And sort of planted that seed of that, that was something that I was very interested in, but, there was still no means to actually manufacture, something like that. And it was really when 3D printing started to hit the forefront. When I saw a 3D printer for the first time, I thought, wow, this is the solution. This is a way that we can, make one-off customized devices, without really thinking about how we're going to manufacture it. 3D printing gives you a lot of freedom in design. And yeah, so it was during that time where we'd just been told we're going to lose our jobs in 2014. And I just wanted to find something positive to do with my engineering skills to help others to get through that difficult time. And I started designing, just started with a finger. And then I started Googling, I wonder if there are any other people around the world trying to do the same thing, and found Enable and made some amazing friends, through the Enable community. And at the time, there wasn't much going on over this way in Australia. Lots was happening in America, but not much over here. And I just decided it was the Raptor Reloaded I initially downloaded to make just wanted to make one hand for one kid. And as Jeremy mentioned, it just changed my life. Mm-hmm. I was actually sitting at my desk at Toyota, and I got sent some photos and some videos of this little boy, Eli. I can move my camera. I've got some photos on the wall here. Young Eli, we made him a Raptor Reloaded, and to see him picking up his toys, it just changed my life. The amount of satisfaction that I got. And here's Eli, he's now 10, with one of our new Kinetic hand designs. So we've formed amazing relationships with some of the families, and I feel, extremely blessed to be doing what I'm doing, because I feel like my family is now global. Mm-hmm. It's just as anyone who volunteers with Enable would understand that feeling. Yeah. Of the relationships that you form with people, and you don't even feel, like the US citizen, or in my case, an Australian. You feel like a citizen of the world, right. And it's pretty special.
It is. I agree with that. So before we move on here, I just want to point out for our audience that we will be sharing the recording of this session. This will go up on our YouTube channel, but it also goes out as an audio-only podcast. So you can get this either way, and we'll make those links available after the session. But because we do share these in an audio-only format, we're going to do some kind of visual stuff today, which is not typical for these sessions. But we're going to ask Matt to kind of show us around his office and do a little bit of other show and tell. So we'll just do our best to kind of describe what we're showing you as we do those kind of on-screen portions, because you will be able to get this recording either as video or as audio. So having said that, let's move on here. And Matt, maybe you could tell us a little bit about your organization that you've set up there, Free 3D Hands Limited. I want to get that right. So tell us about that organization, the business model, your mission, your goals, etc. Just tell us a bit about that organization.
So we formed as a registered charity in Australia about 1.5 years ago, in 2019. And, we were very lucky, I suppose. It started with me, finishing it up at Toyota in 2017 and deciding to use my severance pay, my redundancy payout, to become a full-time volunteer for 2 years. So I was initially working out of a single car garage with all of my 3D printers set up. And I just ran out of space very quickly, and I had the opportunity to move into a large factory down here on Phillip Island about 2 hours south of Melbourne. And, I just thought, you know what, let's just go all in. And we just leased this place for 1 year. And things just kept continuing to happen. And we got more support, and we had a large legal law firm down in Adelaide offer to work pro bono to set us up as a charity, and things just kept rolling from there. And almost 2 years later, we're just continuing to, I suppose, just increase our vision. It started as one hand for one kid, and we just had so much support from people, and large corporations are starting to jump on board too, which is quite exciting. And we're just hoping to become, the initial thing was to have as many printers as we could and make as many hands as possible. But we know, there are, the World Health Organization estimate that there are over 1 billion people in the world who need some sort of assistive technology, whether that be wheelchairs or walking sticks or prosthetics or orthotics. And when you look at the scale of that problem, regardless of how many 3D printers we have here, we're not going to be able to even scratch the surface. So my thinking is starting to change, that we want to become a design lab here. Obviously make hands as a way of prototyping and testing, with maybe hundreds or thousands of people, but certainly not millions. And that's where, incredible groups around the world, like the different branches of Enable, are really going to bridge that gap. The most exciting thing to happen here, after releasing the Kinetic hand, is to see photographs of Enable Polska over in Poland, already downloading and making the Kinetic hand. And that just, for me, really just melted my heart. That's the true power of open source, as we all know. Like Steve Wood with a gyrobot, as some people would know him, with the Flexi hand, and all of the guys, with even the cyborg beasts, and your Raptors, and your Raptor Reloaded, and your Phoenix hands. And just when, those designers, when you actually see how quickly that can be adopted and implemented, it's really exciting. And so, in short, sorry to make a very long-winded thing. At Free 3D Hands, we plan to really use world-cutting technology to continue designing assistive devices to release open source for the community.
That's really cool. Could you take us on a quick virtual tour of your office?
Sure.
And make sure you describe everything, so that the people who are just listening will be able to kind of understand.
Thanks for the reminder, Jen. It's very easy to forget. Thank you. I'll turn my camera around so I can actually see. So I'll just go outside. It's a beautiful, beautiful Friday morning here in Australia. So just to show the scale of the factory. So we've got quite a large factory now. Jen, when Jen came out, I was still working out of my my garage, but we've moved into this amazing factory. So if we walk through, we've got our assembly area downstairs. We've got a U-shaped cell that where we have our volunteers assembling all of the hands. And all along the wall, we have some of the photographs of the recipients that we've made hands for, as well as what we call the wall of gratitude, which is was actually a bit of a go at Donald Trump when he started building his wall. I thought, well, I'm going to build my own wall. The wall of gratitude, thanking all of the kind and generous people who made this happen. So all along our 5-year journey, these are all of the names of people who have supported us. We've got our wall up here from some of the corporate sponsors and different groups, different support groups up here that have supported us with our trialing and designing. And then we'll take you upstairs. So we have all of our 3D printing upstairs. But downstairs, just before we go up, also got my Michael Jordan inspired basketball ring here for when I'm designing and I get a little bit stuck. I come and shoot a few hoops and it clears the mind. Just taking your mind off the problem sometimes is the best thing. So we've had some amazing support from Tesla. So we have 109 solar panels on the roof now. So our entire factory is powered by the sun. With 109 panels and 30 kilowatt hours of power, we can run our factory day and night from the power of the sun, which is just awesome. So we've got about 30 3D printers up here. And you can see that we tend to use the same model of printer. We use FlashForge Creator Pros. Really for no other reason than it was the first brand of printer that I got, and I didn't want to have to be changing the firmware, well, the slicer file every single time, I wanted to make a hand on a different printer. So we've got two types of printer: the Creator Pro, which is about 800 US, and then we've got the FlashForge Finder Lite, which is about a $300 or $400 US printer, which is really at the bottom of the food chain of printers, I suppose, even without a heated bed. But you can see, it prints very, very good quality parts. We've got some of the parts that we've printed to make a hand here. And you can see with the design of the Kinetic hand, you don't need any support material whatsoever. So we've made sure that we design that into the hand that it can be printed without any supports. And we just use PLA Plus, which is slightly stronger than regular PLA, but we also use PLA. So that's upstairs. Got all of our different colors here. And we've got a bit of a filament storage area up here. So we carry quite a few colors for recipients to be able to choose whichever colors they like. And heading back downstairs, I'll take you into our lab, and this is where I spend most of my time, either designing or prototyping. So we have our 3D scanner area, so we're able to make plaster casts of recipient hands to scan those using an IronScan Pro 3D scanner, and then to make a digital model of that and do a virtual fitment. But when we can't do that, we've developed a scaling system for our hand where, similar to how, with the scaling systems that enable users. Here's where I haven't hardly taken a breath. I'm short of breath. So here is just where I do a lot of my prototyping and designing computer. We've had some amazing support from Hewlett Packard to build us a dedicated CAD station, because some of the software that we use is quite heavy on resources. So this here is what I was wanting to show. This is how we come up with our organic design. And we use a program called Geomagic Freeform Plus. And this is a virtual clay modeling software. So this was the design, the lump of clay that I used to start designing the Kinetic hand. And what's significant about this software for organic shape modeling is that it literally is a lump of clay. And we use a haptic device called a Touch X. And it's literally a robot pen in 3D space that we can carve and sculpt. We can actually feel the part. So as I'm pushing here, it's actually resisting my hand, and I can actually feel the contours of the part. So if I was to just want to bend and twist this part, I can.
Uh-oh.
Uh-oh.
We lost him. Matt, come back.
Right at the good part. That says still connecting to audio. There he is. Can you hear us now, Matt?
I can hear you. I have no idea what's going on here.
Hey, yeah, we lost you right at the good part. You were just showing us the haptic feedback tool.
I'll have to report that one to Samsung. Hey.
So here, let me see if I can get you back out of video here. There we go. You should have a request to start your video.
Here we go.
There you are.
I apologize. We're on the laptop. Take 2.
Yeah. So we lost you right as you were starting to show us the haptic feedback tool and how that works with the clay modeling. I don't know if you wanted to continue that. Let me switch us back to a speaker view so we can see you full screen here.
So I'm holding my laptop now, so hopefully I can still show. But
okay.
So we were able to see how I bent and twisted the thumb, inserting a plane. So, using this software and the haptic tool, we're able to very easily manipulate the clay model. So you can see where I've selected and then very easily bending and moving where traditionally in a CAD setup that would be very, very difficult to modify the design. We're also able to go in and sculpt, so we can easily, cut out, set the clay hardness.
Oh.
Try and hold my laptop now. So you can see how quickly we can just cut through the clay.
Yep.
So you can remove fingers, you can do anything, and then we can smooth that as well. So you can then make it very, very organic. So it's almost like you've got a piece of clay sitting in your hand.
That is wonderful.
This is literally made from a lump of clay.
That is very powerful.
Cut out here and bent the thumb around from where it was. And then we import that into, sorry if you couldn't see that. Then we bring that into another software package that we use, which is SolidWorks.
Yep.
It's quite an expensive piece of software if you're not using a cracked version. So we've been lucky to be sponsored by Dassault Systems, so we have access to this. And for our next manual, we're also getting some other software through them as well, which will help us with that to improve our manuals even further as well.
That's great.
So with the combination of the clay modeling software, where we're then able to come in and do all of our engineering and simulation in SolidWorks, it's just our only limit now is really our own imagination.
Mm-hmm.
Yeah, and there's something really special about this, because you pointed this out earlier in the session that your ambition is to become kind of a design house and rely on the broader community to help with the production side of things, which I think is brilliant. Not everybody is going to have access to these kinds of very advanced tools that you just showed us, but one skilled individual like yourself can put those tools to great use to create some great designs, share those with the open source community, and allow them to be leveraged by the global community. I think that's just a wonderful model to be able to talk about
that haptic arm, for example, just the arm itself is worth $20,000 US.
Yeah.
Right. And we've just been so fortunate to have such amazing support to get our hands on those tools for the open source community. Even Enable Polska the other day sent through some ideas for modifying the kinetic hand, taking away the ring and the middle finger, for a recipient. And then, we can use those tools, and I quickly modified it and sent a model back and said, hey, how about this? This is my idea, test it against your idea and see how they go. So to have software like that and the support of these corporations, right, helping us to use these software packages legitimately,
Yeah.
Right, on cracked copies.
Yeah.
For the open source community, for anyone to use. It's quite exciting, and I'm
It is.
really, really excited about the next few years ahead.
And that's what always, amazed me, and I find so wonderful about 3D printing technology when you combine that with what you're doing, because to me, it always seemed like almost like a form of, it's almost like teleportation. It's like you can come up with a design where you're at, share it with somebody by email or, online, and they can print it on their 3D printer halfway across the world and be holding it in their hand hours later. I mean, that's just a fantastic capability. So like you said, for collaborating with people around the world, you can do the design work there and they can be printing it out hours later. It's just phenomenal.
Yeah.
And even tools like this with Zoom to be able to, we're in 3 locations, or, just the presenters here. It's just incredible that we can have that live sharing of knowledge and ideas. It's great.
Yeah,
Sorry,
that's how the first 3D printed hand came about. Was Ivan and Richard were 10,000 miles apart. And Richard's in South Africa, and we were here. And the first thing Richard did was send a clay model of his hand to the US, and then Ivan made the design and would send the file to Richard and back and forth, and we, without 3D printing, that would have never been possible.
Right.
I mean, we could have done like a CNC machine kind of metal one, but it was really cool that because of the time difference, Ivan could send a file, go to bed, wake up, and Richard will have printed it out, assembled it, and held it up, and Liam would be able to test it out and give feedback, and within a couple days completely redo it all. So it's really cool to see that this is still how Enable and Free 3D Hands are collaborating. I mean, before it was just 2 guys, and now you can throw something up on one of our Facebook pages or in the maker community in general, and by 5 p.m. you've got 4 or 5 different people who've taken it and played with it and given you suggestions.
Yeah, it's just amazing, isn't it?
Yeah. Well, what were your early impressions of the first 3D printable hand designs? And what did you want to do differently?
Well, without any sort of criticism whatsoever, I suppose I'd make an analogy of the Wright brothers plane. Less than 100 years ago, Orville and Wilbur took off and over Kitty Hawk, and for the first time, and then less than 100 years, other minds have come together and improved that we're landing rovers on Mars.
Right.
I saw it as a really great starting point, like the Wright brothers plane, and I just thought, what? Imagine if we had access to this, the world-class design tools. A lot of the design work was being done on freeware software, and just from an engineering perspective, with the experience that I had from my days at Toyota, my job was to make things simpler and better, to improve processes. I was actually a leader in what they call karakuri, which is simple devices. So my job was to make processes simpler and share that knowledge with other Toyota manufacturing plants around the world. So looking at the initial hand designs, not criticizing them, but my mind went straight to work on how do we improve them, because you can always improve on a design. And the great thing I see within the Enable community is people always trying to find ways to improve on the designs, that's the whole point, right?
Right.
Open source community is the opposite of patenting an idea, which is allowing yourself to make it, but stopping others from replicating or improving on your idea.
Right.
So, I saw the original. Here's one here, and one day I took this to a recipient, and it broke within 2 minutes, for the reason that the younger brother, being autistic, was jealous that he didn't have one, and threw it as hard as he could at the ground, and broke some of. But that showed me where the weakest parts of the design were. So my job was then to try and find a way to design a hand that would survive a hammer test, literally and smashing, beating the crap out of it, right? And the way that I'm getting closer to that design. I'd be quite confident to throw this across the room and it wouldn't break, this new Kinetic hand design. But it's actually by building in dampening systems between the rigid joints, by having flexible hinges. You're absorbing that impact. So I can get this hand, and I'm not sure if you can hear that for the listeners, actually whack, and it doesn't break. You can bend the fingers the opposite direction. You can twist them to the same level as a human finger, where with a rigid joint, with a snap pin, you can't do that. And the nature of 3D printing parts are typically weak. You've got to consider 3D printed parts like a piece of wood with a grain, and everything has to be designed to suit that grain. You can still use wood to build structures, but you need to take that as a consideration and think, considering all of those things into the design process. Designing the hand was very important. And the hand that I gave Eugen about a year and a half ago, look, for those who can see, looked something like this, and it was still very rough. And we've improved on the design a lot. But one thing that I was lucky to do when I went and visited Eugen over in Seattle was I was sent by one of our largest banks in Australia on a world tour to visit anywhere that I wanted and anyone that I wanted to expand my knowledge on bionic design, prosthetics. I did a stint in a prosthetics clinic in Denmark, visited universities and labs and conferences through Japan, Germany, through France. It's just this incredible world tour, and some of the learnings that I had during that time were just mind changing. Just completely, just incredible. And even visiting Open Bionics over in Bristol, they're just an amazing group of people. And that Joel's suggestion to me was that I should perhaps remove one of the finger joints, not to make it exactly like a human hand, because really, your distal phalanges here, they don't really do much when you bend your finger. And a lot of the enabled designs don't have that extra joint in there, and that allows you to reduce the angle of bend in the design. So really, your amount of bend is the distance of the tendon between each of the phalanges added up to the angle within the wrist here. Yeah. And we've been able to reduce that to about, I think, 17 degrees. So those who can see, bending the wrist of this hand, you don't actually have to bend it much. And that was one of the key focuses for me with this design, was to reduce that angle. Because there were a lot of kids that I couldn't make a hand successfully for because they had such little movement in their wrist. Right. So without creating too much friction in the system, trying to reduce that angle and also there are a lot of experimental designs with the Whipple tree design that I looked at and played with a little bit. This hand here actually has a Whipple tree mechanism in it in the Raptor Reloaded, I think it was. Correct me if I'm wrong.
That's the Phoenix there.
That's the Phoenix, is it? Right, There you go. That's the Phoenix design. But I tended to find that all of the strength of this hand is reliant on a tiny piece of plastic that's 3D printed. Mm-hmm. So I wanted to take away that, and if that fails, that tiny piece of plastic fails, then the entire hand will fail. So I wanted to make it less prone to fail by having each finger on its own separate flexible tensioner, so that fingers can continue to travel and grip around objects better. But, we're still getting there. This is the first iteration to release. We're working on the next design now, based on feedback that we continue to get, and that's how you improve, is through continuous improvement, through customer feedback.
Sure.
And now that we have incredible people all across the world manufacturing them, and we can get endless, infinite feedback. So if anyone's out there is attempting to print one of these hands, with any feedback that you have, we'd greatly appreciate to build into our design.
Thank you, Matt. How many have you made for people so far?
We lost count a long time ago, actually, but I think for this particular design, maybe 50 or 100. We're probably in the couple of hundred for the hands, but we make lots of other stuff as well, which I should share a bit more. Simple, very, very simple devices. As I mentioned, my job at Toyota is to make something as simple as possible. Making flexible cuff adapters for wrist to hold a skipping rope handle, for example, out of a flexible urethane that can adapt to any handle shape. And then things like to hold a tennis ball. So this is 69 millimeters wide cup that slots into that same adaptive cuff to serve a tennis ball. That's someone with a hand difference. That's something that they will struggle with, right? Serving a tennis ball, you'd have to balance it on the racket, throw it up, turn the racket around, and then try and hit the ball. And to do that consistently is very difficult. So making simple things like that, which have been very, very popular. We've sent hundreds and hundreds of those through Europe, actually, to make simple things for left-handed piano. I wonder if I've got one around. I have to find it. Here we go. This is a simple device that spans one octave of the piano. So CGC, DAD. And you can arpeggio with the left hand just by rotating the wrist. That actually sounds really cool. Or the Kinetic finger. This was actually before I started making the open source hands. I'd always have in my pocket when I was walking around Toyota in about 2014 was this Kinetic finger design, which is similar to the Nick finger, I think. There's out there, but attaching to the wrist and using the finger stub to open and close. But that's utilizing the flexible hinges as well. Yep.
Excellent. Well, we're going to have you back to talk about all these great devices you're building, but today we want to talk about the Kinetic hand some more. So we'll come back to those. We're gonna ask you about these other designs you're working on, but I want to make sure we have some time to get into some of the details on the Kinetic hand here, because there's really so much good stuff to talk about. While we lost you for a moment there, we were starting to talk about this a bit, and I was pointing out how the first thing that I noticed when I downloaded this and I started looking through the files was I opened up your documentation and I was just blown away. I mean, you've got a 99-page documentation file for the Kinetic hand, which does a beautiful job of walking you through step by step everything that you need, all the parts that you need, how to print them, everything from print settings to scaling methodology. I mean, it's all in there, and it's so easy to read and easy to follow. So I want to congratulate you on that. Is that something that you had experience with before, doing documentation like that?
It was at Toyota, making what we called standardized work. But I think I look at it and I think, I wish I had spent another 6 months putting this together. But, I was so keen to release it that I released it. But my initial idea was to make something similar to a Lego manual. Children all across the world are able to put together very complicated Lego models. So I wanted something that was very visual, didn't have a lot of wording, so then it would cross language barriers.
Absolutely. You did great.
However, as it turned out, I still needed to use quite a few words in there. because I wanted to share my learnings as well.
Yeah.
Share my mistakes, when assembling a hand. But there's so much stuff that I want to continue add to it, like printing on glass, for example. I've found is much better than printing on any other print surface.
Yep.
How to get around using brims with printing rafts and brims it's a wasteful process. Sometimes it's a necessity, but how to get around that, what sort of adhesive to use on the bed. So I'll be continuing to add to the manual with different versions, and that's the first thing I want to do, is to focus more on how to get a good quality printing result. Because I think it's very, very important for our community to be consistently providing not only good devices but world-class devices to show developers around the world that this is an amazing technology that we should be embracing. We've received lots and lots and lots of criticism right along the way through established organizations. Mocking 3D printed hands as a weak technology. If you leave it in the car and it gets hot and a child puts it on, it will burn their hand. Just like a lot of scaremongering, fishing line, downplaying the technology. But what I want to show is that, we can make devices that are world class, that anyone with a hand difference would be proud to wear. That there's no compromise. If you're sending them to countries where people currently can't access or afford them, that it's not, well, something's better than nothing. No, it's to say, no, this is something that anybody, even in the developed world, would be proud to own.
Yeah. So in other words, ensuring the success of people that choose to make one of your designs, making sure that they have the documentation and the guidance they need to be successful. And that actually leads into the next point, which is the next thing I noticed was how you had all the files organized. You've got all the STL files, both grouped and as separate files. You've got them oriented in a way that ensures optimal printing results, where they're oriented so that they have a nice flat surface sitting on the bed, but they can still be printed without any supports like you showed us earlier. So I felt like there was a lot of thought that went into every detail in terms of how the parts are oriented, how they're grouped together, the instructions that go along with those. So it sounds like that was all stuff that you thought through carefully as well, right? In terms of the parts orientation and the grouping of those and that sort of thing.
Yeah, I think that's a really, really important thing to give every detail to ensure that the orientation is right. And to also we were able to scale the parts. To have different scale in X, Y, and Z directions.
Yes.
To then present the positions of those as they would sit on the hand, so that you can scale them in the directions that you want, and then reorientate those into the print directions.
Yes.
So to really show that, to make a hand effectively, these are the exact steps that you need to take. It was a lot of work. Initially, I thought maybe 20 pages, the manual, and then it was pushing out to 40, and then 100. And I thought, 99. Yeah. I thought, all right, let's just stop it there, and
well,
it overwhelmed.
I think I said this while you had dropped off momentarily, but I think you really set the bar. It's the best documentation I've seen, and I really hope others follow your example there, as I've always maintained that having great documentation like that is extremely important to adoption and to making sure that people are successful in making these. So I was just thrilled to see the work you had done there, and just making it as easy as possible. I mean, my first time through making one of these Kinetic hands, I had no problems. I never came to a point where I felt like I was stuck and I didn't know what to do next. I just had to follow the step-by-step instructions. It was just really wonderful. Now, the one part of this that I think would be challenging for many, and myself included, is, as you pointed out, there are flexible parts in this hand. There are flexible sort of interfaces between the fingers, a little sort of pads that go in between the fingers, and the joints, the pads that go into the fingertips. These have to be printed in something like a Ninjaflex, so which has about a 85A shore hardness. Now that's pretty challenging for a lot of printers to handle. You're best off if you have a printer that has some kind of a direct drive extruder, as opposed to feeding through a Bowden tube. And you and I had some conversation about this previously, but maybe we could just spend a minute talking about that, some of the unique challenges of printing with flexible filaments, and what are a couple of the tricks that you can offer to help people be more successful in printing those materials.
That's really great. Thanks for the opportunity to discuss this, because I had such a nightmare learning how to print flexible materials, especially Ninjaflex. I think it's the softest and most difficult to print, but I believe it's the best material that I've printed so far. But to print it is really, really difficult. The fact that it is so soft, and as you're extruding with the gears, it can actually kink it and tuck it into a pocket in your, and it doesn't ever even make it to the nozzle, right? And so I think giving it as much freedom to have no resistance at all through the extruder is fundamental. Every time I print, I work out how many meters I need to print of the material, and I actually unravel that from the reel itself, so that there's no resistance whatsoever when you're printing it. Also, just having your printer just kept in tip-top condition. I actually have a printer dedicated to printing Ninjaflex, 2 printers actually. So I don't print PLA or ABS or anything else on this printer except for Ninjaflex, for the reason that you can get slight blockage of PLA in the nozzle if you're trying to feed the flexible filament through. It's not actually able to push out the PLA that was in there previously.
That's right.
So trying to get have a nozzle or one extruder. If you have a dual extruder on a printer, okay, keep one for your flexibles, keep one for your rigid materials. Reducing that and playing around with your temperature settings as well. Mm-hmm. I print the Ninjaflex at 230 degrees.
Yep.
And it seems to almost to the point where it's almost starting to run by itself out of the nozzle before it's printing.
Right.
Yeah, it's really quite tricky, but we can get some really great results with the Ninjaflex. This is a band for the sensors that we're making for our bionic arms and things that we're making out of Ninjaflex. Fantastic, but it's a real learning curve. And if anyone is having any trouble printing Ninjaflex, please shoot us an email and we'll share what we know. We're successfully printing it on the FlashForge Finder Lite, which is the cheaper version of the Finder printer.
Terrific. Yeah,
it is touch and go. Sometimes you'll get a fail, and then the next time you print it, it'll be good. You pull out the filament and you find it's all kinked up, cut it off, feed it back in, and away you go, and you don't have a problem. But I suppose the one fortunate thing with the design of this hand is that it doesn't use much flexible filament. Right. It's maybe about an hour to print the hinges and an hour to print the palm. So if there is a failure, it's not the end of the world.
Absolutely. Well, I wouldn't be surprised if some of our Enable volunteers take you up on that offer and reach out to you, because I know that's a tricky area. Yes. And the other thing I would just point out is print slow, keeping the speed real slow with flexibles.
Yeah. Too. Maximum speed, 20 millimeters a second.
Yeah.
I don't know what that is if you deal in inches.
No, that's all the 3D printing stuff is metric. So yeah, that's about what I use. So excellent, great tips. Thank you for that. All right, so now you mentioned the sizing methodology, which was another thing that really impressed me. You've provided several different sizing methodologies. You have a virtual kind of a scaling approach, similar to the method that Peter Binkley showed our community, where you basically import a model of the hand or a 3D scan of the mold of the limb, or you can use photos, and you bring that into your CAD software, and you basically overlay the hand model on top of it and visually do kind of a virtual fitting. And you showed an approach to do that, but then you also show a version where you can use photographs or direct measurements from a hand, and you can size these parts, like you said, in all 3 dimensions. So you're not just scaling it up or down, but you can actually do custom scaling in X, Y, and Z dimensions to get a truly custom fit. And you've provided some great sort of reference matrices in your documentation where you can look up if this measurement is such and such, then here's the part that you need to use, and just a tremendous level of detail that went into that sizing methodology. So any comments or notes about what went into that and why you took that approach on sizing?
Wow, that's a long question. Yeah, it was really just due to, we've obviously made a lot of hands, for people, and we've got a lot of different, information, levels of information coming back. We were very specific in, and as we laid out in the manual, of what's required to standardize the measurements. If it's sent with a ruler along the edge of a table, that the hand must be level with the ruler, etc. But obviously you get people sending photos that it's above the ruler and below, and just to highlight those fundamentals that you've got to get right when the photos are sent through. If not, get them resent. So that's if you're at a long distance from someone. Obviously the best is to be able to get a 3D scan, or actually the recipient in person. Virtual fitment, but I wanted to put into the manual doing that in freeware, so you don't need the expensive CAD software to do that fitment. In the manual, we've used Flash Print, which is the free software that comes with any of the FlashForge printers.
Right.
And you could do it in Cura. You could do it.
Yeah.
Same thing, right? But loading it into the slicer to do your scaling, and loading the scan of the hand into that, and then scaling the palm to suit.
Yeah, this is very innovative, and again, opening it up to more people, because everybody has that slicing software. So I love making it easier and requiring people to have less of that specialized software. So I think that's great. And then you also introduced different components, like you have these padded components that can actually go into the palm cavity, because of course we have so many different palm anatomies out there. Some people have more, some people have less. And so you actually created a number of different inserts that can be printed and inserted to take up that space, which again allows your hand to be used in so many different types of anatomies, which I had not seen before. The
initial design of the Kinetic hand, we had full palm.
Yep.
We had a short palm version, so you can see it's full in here. But as you mentioned, every partial hand is different.
Yeah.
So it was at that point where I thought, well, let's make every hand a full palm, and then have different size inserts, soft inserts, to fill that void so that the hand doesn't slip forward.
Oh yeah.
Incorporate that into our measurement system.
Yeah.
Have the insert type along here. So for each scaling, each size, you can work out which insert type to use.
Yeah, that's terrific. And then
there's a lot of it was actually more work to put the manual together than actually designing the hand.
Well, you can see that it shows, but it was time well spent, because I think that you could tell that a lot of time and energy went into figuring all those things out. But it's such an enormous benefit to the people that are putting these together. It was immediately apparent to me that just so much testing and trial and error had gone into this, and it really shows in the maturity of the documentation.
It was a massive benefit for us. It was a massive benefit for us as well in putting that documentation together, that when we're training our volunteers in-house.
Oh, yeah.
As a training tool, right?
Oh, yeah. A terrific training tool. Yeah. You know, it's
So,
funny. In fact, you may have seen in the past, I've done some videos, like, video assembly tutorials for some of the enabled designs. And it's something that I like to do when I become familiar with the design and just share that with the community. After making this design, I kind of thought to myself, I don't really think there's any value in doing a video on this one, because you did such a great job on the documentation. I don't think anyone needs a video tutorial. So
oh, wow.
it's that impressive. Yeah. It was
there
very
are different ways. People have different ways of learning.
Yeah.
So, to show visually hands-on is also, I think, important. And as I mentioned before, with the sponsorship from, Dassault Systems, with a product called Composer,
Yeah.
which can make, animations quite easily for animated tutorials with exploded parts and this. So with our future designs, we're hoping to make it very, very visual with the 3D models that we've got.
Awesome. All right. So I've
one
got
you can print out.
I've got a couple more questions here about the Kinetic hand, but I just want to pause and remind the audience to feel free to use the Q&A panel. I don't know if anyone out there has had a chance to try to make one of the Kinetic hands yet. If you've run into anything where you have questions or comments, please share those. Use the Q&A panel, and we'll bring those into the conversation here. But I wanted to point out something else that I noticed in going through this documentation and the design process was the tensioning. One of the problems that we've had for a long time with the Enable community is in teaching our volunteers to set the tension level. So when they put a device together, you don't want it to be assembled so that the hand is completely straight across when the fingers are extended. You want the rear portion that goes over the arm, you want that to be at a bit of an incline, so that when the person bends their wrist to activate the device, they don't have to bend it, at an uncomfortable angle. They can just bend it a small way. And so you want to make sure that the level, the tensioning level is set such that these angles, the angle of the palm compared to the angle of the bracer, is correct. And you had a really creative approach to doing that. In your documentation, you have it so that when you're running these non-flexible cords, you have people do that where you can actually connect the bracer to the palm using these flexible hinges, and you bend them together so that these two pieces at the bracer and the palm meet one another, and you use that to tie off the cords. And then you inside, so underneath the cover that's on this bracer here, for those that are watching, underneath that cover there's kind of a grid of all these different holes where the little, what we would call the tensioner pins, get attached. And so after you do that, after you set the tension level, using the palm in that upper position, then you basically just slide those tensioner pins down. I think it was 4 spots on the grid, right? And by moving them down 4 positions, you end up with the hand at exactly the optimal angle, without having to struggle with trying to find that angle on each of the individual cords. Now, I might not have explained that very well. It's hard to do on video here, but I just thought that was brilliant, because we've had so many people that have struggled at finding that optimal angle, and you've made it kind of foolproof here with that approach. I thought that was brilliant.
Well, thank you. And regardless of the scale, because the pitches of those holes increases as well with scale, it always, you move it forward and it'll always be the same regardless.
Yeah.
And, then you have the ability to, when you're going through your tuning, to move those individually backwards and forwards to
Right.
suit where you'd like them to be. And you can do even finer, which I didn't put in the manual, but I will add it. The pitch between the holes may be only a few millimeters, but that might make a difference with, the lead on the fingers.
Oh yeah.
You can actually twist the tender, turn it in 1 or 2 turns, and that will actually close it up even more. So you can do even finer incremental tuning as well.
Excellent.
In the tendon before you insert it.
Yeah. And then those pins, what we're calling the tensioner pins that the cords tie off to, you actually have those being printed in the Ninjaflex as well, which I thought was very creative.
That's correct. So that adds the flexibility.
It gives you some flexibility in your grip. And interestingly, I also found it easier on the assembly process. I found it easier to run the cords through when I could kind of bend the pins up to get access to the hole. So it actually ends up making it easier. So just so many little details that I think were so smart. And it just, to me, it became very clear that this is not something that somebody just threw together. I mean, you could tell that there's years of work that went into this. It really shows.
It was close to three years work, and you know, even just mentioning, you know, the ability to feed the tendon through these holes, you know, they did start off quite small, and that was the struggle, was to, you know, to feed the tendon through, and then I'd have to use like a screwdriver to try and push the, you know, so okay, increase the size of the hole. So it was very, very small incremental improvements over that time to get over those struggles. You know, as we had, you know, new volunteers coming in and assembling the hands and just looking at and getting the feedback on what they struggled with to determine the steps for putting the hands together as well. You know, we have putting this this soft palm cover on very early in the process, where initially we were putting this on last. But then, you know, if you make a mistake and you over tighten one of these screws and you start to strip that, you know, the material in the palm, then you've done all of that other work and you basically have to pull it all apart. Right. So it's better to make that mistake early. And if you fail, then you haven't done all of that assembly work already. So it's had all of those sorts of things planned into, you know, the order of which things were done. And look, if anyone has feedback or any better ideas or easier and more robust ways to do things, we'd love to hear it.
Absolutely. And then, you know, the only other thing I'll point out is because of the way you design this, it means that you don't need a lot of hard to find assembly materials. The components that you need for this are pretty basic, right? I mean, you need some screws, which are, you know, readily available sizes. You need some non-flexible cords. We usually use a fishing line. I think that's what you use too, right? An 80, I think.
Yeah, so we don't use nylon. We use a fishing braid. Nylon stretches.
Yep.
So we use a fishing braid, and the brand that we use is quite expensive. It's only available in Europe, so we import it in 2,000 meter spools. Yep,
that looks like about what we get too.
Berkeley Black Velvet, and this is what Open Bionics are using.
Okay.
It's a fantastic braid. It's a little bit expensive, but you don't use much of it.
Right.
But yeah, any fishing braid is that doesn't stretch is going to be good. But this, I love it because it's 0.3 diameter and it's 100 pounds strength.
Oh so yeah, it's strong stuff.
Awesome, right?
Strong stuff. So yeah, I mean,
it'd be at least 0.5 diameter.
So there's not a lot that you need. You need a couple of Velcro straps. You need those cords, some screws, and that's really about all there's to it. So it shouldn't be hard for people to find these materials. We do plan to offer assembly materials kits for this design through 3D Universe. We do have a couple of other kits available for other designs, but we would like to support this design as well. So expect to see a kit coming soon that has the materials that you need. Though if you're in another area where it's hard to get those from us, you shouldn't have any problem finding these materials. So I think I want to share a comment here that we have from the audience. Renee says, my students and I attempted sizing and printing what I believe was the original Kinetic hand design 3 years ago for a gentleman in our community who wanted a realistic hand. I'm excited to share this webinar and the improved model and documentation with them. I'm hoping we can try again with more success. Thank you. So
that was Steve's flexi hand they might have been talking about. Maybe the flexi hand.
Maybe, yeah. Renee,
I wasn't happy. I wasn't happy with the original prototype that we used to get to this final, current result. We didn't release that open source. So perhaps that was the flexi.
Possibly.
Hand.
Okay. So Renee, I don't know if you want to type an update there. Maybe you were dealing with the flexi hand or the flexi hand 2 most likely. But yeah, this is, I can tell you from my experience that this documentation is going to give you a really good experience. If you haven't tried out the current version of the Kinetic hand, absolutely give it a go. I think you'll have great luck with it.
Yeah. So
as mentioned, we'd love any feedback or questions. Always happy to
yeah.
just an email at info@free3dhands.org. I'm not sure if you can share that when you post this with the group.
Yep.
Excellent. We will. Yeah, we'll be putting up a blog post kind of summarizing this session, and we'll include all of these relevant links and email addresses and everything people need. Let's see. I have one person in the chat was saying that the QA panel isn't working for them. Now I'm not sure what that would be.
I think John, that popped up before John said that the QA.
Yeah, but I do have other people using the QA panel.
John.
So yeah, hi John. I don't know. Maybe give it a try again, or if you want to just type any questions into the chat, that would be fine too. We'll try to keep an eye on both places there. But meanwhile, I think that's the only question we had in the queue, so we can move on for now. I'll keep an eye on the chat.
Yeah.
But I definitely do recommend if you are able to do the silicon molding for the grips. That's another thing. I think that I'm not sure if we're the first to include it in a design, but
it's in the documentation. Yep.
Yeah, it's in the documentation to use a two-part skin-safe silicon to make the finger grips. That was the thing I think we struggled with in the past was depending on the hand size with the Lee Tippy micro gel, I think they are, even the size 0, getting them to fit, the smaller hands was always a struggle. So we've got a 3D printable scalable mold that we're able to, to make customized grips.
Yeah, I really like that. And it's one less thing to try to print with the flexible material. If you can just do the molding, that's a lot easier.
Yeah. And then they're much grippier as well if you're able to mold them. Silicon is fantastic. And usually we will for each hand that we provide, we will actually make 2 molds. We'll make 2 sets of grips. We'll fit one to the hand and send a spare with them. So if they if they wear out, they can put the others in and then let us know, send us another set of grips. So there's no downtime in replacing those.
Mm-hmm.
Got it.
We managed to there's a company up in Brisbane called iOrthotics that using their HP multi-jet fusion nylon SLS printers to make our hand as well. But we find that that technology doesn't suit this design. This was designed for FDM. It was almost impossible to clean out the white unfused powder from the textiles.
Yeah.
Almost have to put it out with a flexible drill. We just couldn't do it. But
exactly.
This technology with some of our future designs, when we make our low-cost multifunction bionic arm as well for transradial cases.
Very nice. Very nice. And yes, Renee pointed out in chat that yes, she thinks that might have been the Flexi hand. So yeah, definitely give them the Kinetic hand a try, Renee. I think you'll be quite pleased. Yeah.
So
he's a very clever man. Steve Wood had the opportunity to meet him over in the UK at Open Bionics.
Yeah, we had him at one of our conferences. He was great to meet.
Lovely guy.
Really nice guy.
There was a lot of things I learned from his design with the hinges as well, because he was, I think, the first with flexible hinges. And we adapted that thinking to have a split hinge which you fit from one side and then force feed it from the other side so that it can't slide out laterally. As you can see, you don't even need to glue them in. They just, just due to the nature of the hinge design.
Really smart.
So when we the first 3D printed hand was had a lot to be improved upon when we decided to put it out there in the world. And Ivan was a puppeteer and a paper salesman, and Richard was a carpenter, and we all collectively decided to throw it out there open source, so that some engineer, maybe named Matt from Australia, might find it and improve it, along with a whole maker community. So it's been really cool to watch over the last 9 years from the time I started, where it's come to, and how much you have improved even just in the last 3 years of the design. Do you have plans for the kinetic hand, and how you might want to improve that even more, and how maybe the community can collaborate with you?
I've already had a few requests from the community. One's to make a terminal device version with a bolt to attach it to existing sockets, perhaps.
That would
Or
be
and also, we're currently working on an elbow-powered design as well. We made one of Team Unlimited's design forearm, but my challenge now is to try and make something that is a little bit more rigid. That's one of the struggles with 3D printing, is making large parts to be strong and rigid. But without excluding people with small print beds is the other thing. We have 400 by 400 bed that you can use the hypotenuse to print almost 500 millimeter parts. But for those people who have 150 or 200 mil beds, the challenge for us now is how do we design something that is truly going to be of use for people to be able to download and make themselves in modular parts without sacrificing strength. So elbow powered device, and the challenge for us is how do we get all of those tendons through the center of the hand to allow us to be able to rotate it without affecting how that's going to affect the tendons. When you can imagine if you were rotating a wrist, the tendons would be pulled if they're on the outside, and it would close the hand. So we want to have a wrist that we can rotate freely into whatever position the user likes to perform different functions with an elbow powered device, as well as to develop a low cost not myoelectric device, but a sensor to have sensors on the arm to sense muscle movement and with contraction of muscle to power devices like we made with our bionic chopsticks. My wife's Japanese, by the way.
I wanted to talk about this.
For my Japanese friend with cerebral palsy, so he's able to grip, but he has no control over his hand. But he's got a lot of different control with his muscles in his arms. So we've developed him some bionic chopsticks, which were about $10 in parts, including the sensor.
But I want to talk about the sensor that you're using there, because that's really unique. And when I know that doesn't play into the kinetic hand, but since you're working on some powered designs, we had talked about this a little bit previously, and I was really impressed by what you're doing there, because you're using it. This is not, what a lot of people are using is playing around with EMG sensors, which try to actually sense the muscles, and they can be very tricky to work with. You get very erratic kind of results. You're using a totally different approach there. Tell us a little bit about how that senses your muscles.
So this here, if we can focus, is a reflectance sensor. So it's often used in line following robots. So it has an infrared emitter and a receiver. And it's really great at measuring distances between about 2 and 3 millimeters extremely accurately and converting that into a voltage from 0 to 5 volts. And they're about $1 each, right? They're stupidly cheap, these things.
Okay.
And so I actually learnt this from a group EXI, Mission Arm Japan, when I was visiting. They actually using it in their handy bionic arm. And that for me was the greatest learning on my trip around the world, was this particular sensor. And so when you squeeze your arm or any muscle group, the overall diameter increases. So if you have a band around your arm, it's actually, if you have a sensor with a soft piece of foam with a reflector plate, and you squeeze that ever so slightly, you're able to put a very, very clean analog output signal to a microcontroller. So even if you had a sensor on your arm up here, just by wiggling your fingers slightly here, you'll get a very clean signal. And what we're working on with that is to get multiple sensors on different muscle groups to look at the timing of different muscles to create a multifunction arm for a very, very low cost.
That's exciting, because just like you said, it's low cost, but it's effective. That's something that we really haven't seen before in the space of powered or bionic assistive devices.
And also, one of the things that excites me as well is, medical devices are often classified as something that has direct contact with skin. So I'm really keen to develop a sensor that can be worn over clothes, right? So there's no contact with skin whatsoever. If I've actually programmed Mario Brothers sounds into this. You'll hear a 1-up once it's calibrated.
Yes.
And you can see, that I'm wearing it over my my clothes, and I'm still able to.
That's terrific.
Right, and that's literally $10 in parts, and that's how we plan to control our low-cost bionic arm as well, with pattern recognition. But and with the Myo sensors, also it's very, very critical where you put those onto the arm. But
yes.
We've written a program for to calibrate. So regardless of where you put on, every single time it can be different, but you're basically calibrating over 4 seconds. So when I push this button and you hear the Mario kicking a turtle shell, it's actually listening now for 4 seconds to max min, and then recalibrating that to the maximum servo.
That's brilliant. Brilliant. All right. So then I have to ask now, what you have any kind of a timing expectation for this bionic hand? When can we expect to get our hands on that?
Oh, look, my biggest struggle has been actually sitting and designing and developing. I've had supported from many directions by a lot of people.
Sure. Well, that's
so
exciting.
6 months is going to be very interesting.
Okay.
We've
Okay.
got people helping to get rid of the noise now. Yeah.
So for people that want to learn more, because we're unfortunately just about out of time, there's so much more here I could ask you about, Matt, but obviously one way I want to remind people of is the Enable Hub. Hopefully people listening in are already on that platform. Otherwise, we'll include the link in our blog write-up. It's hub.enable.org with a dash in enable, so hub.e-nable.org. I was glad to see that Matt has joined us on the Hub, so that's one way that you can interact with Matt, ask questions, you can post things there. We have, in the Hub, we have our Enable devices catalog. The Kinetic hand is in there, along with links to all the files, documentation, everything that you need, as well as badges. We've added into our digital badge platform, we've added in badges for those who make the Kinetic hand. So you can now earn a digital badge for the assembly and fabrication of the Kinetic hand. So the Hub is one place that you can kind of engage and try out the Kinetic hand and learn more and ask questions. Matt, how else can they reach you if they want to learn more or interact with you?
Well, for those who are still on Facebook, we have a Facebook page where we're always updating what we're working on. Some of the recipient stories and ideas we share freely on that, which is at Free 3D Hands on Facebook, FREE, the number 3D HANDS. You can follow us on that and on Insta as well. Our Facebook page is most regularly updated. But as Jeremy mentioned, I'll be checking the Enable Hub quite regularly as well if you've got any questions.
Yeah, and this is something that I have to point out because John brought this up in the chat. You mentioned that some people had already asked about a terminal device version of the Kinetic hand, and I just want to echo that. As John was pointing out, I don't know if you're familiar with the NIOP system, NIOP, which has been developed by Nate Monroe and others. It's a tremendous system that offers some great new options, including a shoulder-driven arm device. But I think it would benefit greatly from having the Kinetic hand as a terminal device option, because currently it's incorporating a version of the Kuawu hand, which just doesn't have nearly as good of a gripping performance as the Kinetic hand offers. So I just want to second that. It would be wonderful to see a terminal version of the Kinetic hand that we can incorporate into that NIOP system, as well as other future devices. That'd be great.
Absolutely. And yeah, collaboration is key.
Absolutely.
So,
Absolutely.
look, I'm really excited. You know, if people are able to share ideas and ideas for improvement, and you know, that's what it's all about, right? It's about making ourselves redundant. And as Jen mentioned earlier, you know, it started off with something quite simple, but you know, and people over time will improve and improve and improve that, and that's what we want. We want, you know, ultimately we're all working towards helping others, and you know, after we're long gone, for that to continue on. And I want to say to Jen, you know, mentioning yes, it was the first device was a simple one, but I think to release something open source that you are not yourself entirely happy with, I think it takes a lot of courage. But that's what really starts the fire, isn't it? You know, to start the ideas, to start that brainstorming, and you know, I do encourage people to, you know, even if it's only half an idea, to share that with others, because you know, when you put your minds together, that's when you come up with incredible ideas and new ways to do things.
Absolutely. I think we covered this, but we did get a question in through Q&A. Ty is asking what sensor is being used for the sensing. He has a friend with SMA with very limited motion. Are there any other details you can give about the actual sensor component that you're using there?
This is one I prepared earlier because I thought I'd be asked that question. So this is, if you Google QTR-1A reflectance sensor. This one's actually made by Pololu. But yeah, you can get, this is just a very common part. There are I think there was a QRE 111 or something, but this is, if you type in QTR-1A reflectance sensor, there are digital and analog versions. We use an analog version of the sensor, and we go in through just the A0, the analog inputs in our Arduino microcontrollers. And this here too is this is a you know, very, very low cost Arduino Nano, about $2. You can buy them on eBay. We buy them by the truckload. You know, we use very, very low cost MG90S metal gear servos, which are about $2 or $3 as well. But yeah, we're also experimenting with DC motors with this sort of thing.
Are those, I can't quite see. Are those like linear actuators?
Well, we're creating our own linear actuators. They're very, very expensive, but these are just $4 motors here with, and we've put an M4 wing nut on here as the actuator to move backwards and forward. We've put in the hand here. Again, trying to find parts that anyone can access anywhere in the world, non-specialized parts. But the beautiful thing with that is it's actually to maintain grip. You can see this finger here is maintaining grip without any power, because it's actually pulling against the thread.
Right.
Screw. So you could be holding, you know, a 10, 20 kilogram bag, walking along, and you're not drawing any power from the battery, right? It only draws power when you tell it to move to a different position. So that's something that's very different than using servos. Servos want to maintain their position, and if you fight that position, it will be drawing power to try and get back to that position. So we're looking at a few different ways to different techniques with our bionic hand, but the key is low cost for us. We're trying to make something for under $50 in parts.
Wow, I love it. Well, we are definitely going to have to have you come back and talk to us about the powered devices when they're ready. That's very exciting to see that coming along. But meanwhile, we'll have plenty to do getting familiar with the Kinetic hands and getting others in our community making those. I think it's a great design and a great contribution to the work that we're doing. So thank you so much.
It's been an honor. It's been an honor and a pleasure to be a part of this. And yeah, as I said, you know, please feel free to reach out anytime to anyone who's listening.
Absolutely. So for those watching and or listening, you'll find the recordings of this on our blog in the days to come, 3duniverse.org. And we'll share some relevant links with you. And so be sure to check our blog out at 3duniverse.org to get the recordings and the links to the things that we've talked about here and sign up for upcoming sessions. So Matt, thanks again for joining us. I really appreciate it, especially with the difference in time zones. I know it was a little tricky to coordinate, but I'm glad you could make it.
Well, no, thank you for your time, and yeah, I much look forward to many more interactions with the group.
Absolutely.
John said, thanks, guys. Thank you, John, as well.
Yes, thanks, John, and thanks everyone else who attended. And we will see you again for the next episode. Thanks, everyone.
Bye.
Thanks.
Bye.
Bye.
Thanks, Matt.